Hello, good morning, everybody, and welcome to another speech of our international seminars on global rivers in the Anthropocene. It's a pleasure having all of you today with us. And also, it's a big pleasure for me to introduce our today's speaker, Edward Park. Edward got a bachelor degree in geography from Ohio State University and later a master and PhD from the University of Texas at Austin, where I have the pleasure to say as well, he was my graduate student. During his master's, he developed a complex remote sensing but field-calibrated method to assess suspended sediment concentration in large river, and as a study case, used the largest rivers in the world, the Amazon River. For the PhD, he continued this kind of research and estimated the most complex sediment budget estimations of the dynamic of the channel floodplain system and the hydrosedimentary connectivity process of the Amazon River using these remote sensing models of fieldwork. And his work gave him the Association of American Geographer Gordon Red Woolman Awards in the USA. After that, he moved to Singapore to work in the research program I developed at NTU, Nanyang Technological University, on Southeast Asian rivers. And then Edward became a professor at this institution. Edward is currently an assistant professor in physical geography at the National Institute of Education of Singapore and Asian School of the Environment, and principal investigator at the Hare Observatory of Singapore at Nanyang Technological University, where he's developing a research program entitled Tropical Rivers in the Anthropocene. He is the principal investigator of 7 projects, including the environmental impacts in the Mekong Delta, another project called Sand Mining in Southeast Asia, and also the leader of the Climate Transformation Program studies in Southeast Asia. Today, Edward is a main reference in these topics and in this area of the world, highly cited in river hydrology and so on, and one of the top 2% scientists worldwide by the new ranking produced by Stanford University in 2023. He got also additional awards in Asia, like the National Science Foundation DDRIG Award of Singapore and the Nanyang Research Award for Young Investigators. He's currently the national representative of Singapore for the International Association of Geomorphology, associate editor for the Journal of Hydrology and the Journal of Environmental Management, and the editorial and is a member of the editorial board of Geomorphology and the Journal Sign of the Total Environment. So I'm very proud of all this success of Edward. And please, Edward, go ahead. The stage is yours.
Hello. Hi. Thanks for the kind introduction, Edgardo. So can you all see my screen? Okay. Yeah, I am seeing it. Okay. So good morning. Actually, it's the evening here in Singapore, and thanks for inviting me to speak in this in this series of the talks in this symposium. It's my great pleasure to share my research to all of you. So actually, I run the tropical rivers group in NTU in Singapore, where I study the rivers mostly in Southeast Asia. And the Mekong is where I have been working for the past many years from different issues from the climate change impacts, looking at the dams, the urbanization, and other the environmental issues. And actually, the sand mining is actually one of the topic that me and my team have been working over the recent few years. So today I want to talk about this the sand mining in the Mekong Delta. It's kind of like the synthesis of our the recent work in this subject. So today my research talk is actually on behalf of my research team, uh, who are listed here. Let me use the laser pointer. Can you actually see this? So Dung Duc Tran, Kaiwan Yuan, Rachel Lau, Sonu Kumar, Tian, as well as the econ. Okay, so as we know, the sand is actually so important for our society because it's used for the construction of the buildings as well as roads, as well as for glasses and this electronics, the industry as well. Actually, sand can be found pretty much everywhere, right? Like the deserts or beaches. Why is it so precious material? But actually, this angular, the sand from the riverbed is actually the one of the only ideal for texture for the construction purposes. And Southeast Asia is actually the global hotspots of the riverbed sand mining, thanks to this all this the lots of orogenic mountains along with the intensive monsoonal regimes, which facilitates the promotes the development of all these big deltas. And when you look at the demand for the sand has been increasing exponentially since the early 20th century. We're still in an accelerating phase, and it's further expected to projected to increase in the future as well. Okay, so this is how the sand mining is happening in the Vietnamese Mekong Delta. As you can see here, normally it's we have like this rectangular the shape big barge with a crane that actually extracts the sands directly from the riverbed. That actually supplies the extracted sands to the sand transport boat that looks like this on your right. Um, as you can see, this extraction, because it's extracting the material from the riverbed, it happens underwater, and that makes it difficult to monitor the sand mining activities. So actually, the starting points of my the sand mining research was actually to quantify the sand mining budgets, to develop the baseline, the information in the Mekong. So firstly, using this sentinel images that you can actually see on your right, and then we first manually mapped all the sand mining boats and created the boat density map that looks like this. And at the same time, we had the riverbed incision map calculated as the difference in the bathymetry between two different years, 2014 and 2017, as you can see here. So we then overlaid the two maps, the boat density and the bathymetry difference, and found a very nice correlation that you can actually see here on your at the bottom left corner, right? So basically, this tells you that the bathymetry difference, right, which is on the y-axis, can be explained by the sand mining, the boat density. So using this modeled relationship, which is a simple regression model, we calculated the annual sand mining budgets, which is the extraction rates, right, for the whole Mekong Delta for the first time. You can actually see the budget was around 38 million cubic meter in case of 2015, which progressively increased to almost 50 million cubic meter in 2020. Actually, there's a reported value of this budget for the whole Mekong Delta, somewhere around 20 million cubic meter, which is actually the sum of all the voluntarily declared amounts of the extraction budget, the voluntary report from the private sand mining companies, which is actually less than half of what we have measured, right? And this actually indicates that more than half of the sand mining budget in the Mekong is actually informal or unaccounted for, or we can say that this is illegal. Well, actually, the illegal sand mining is the biggest challenge in the Mekong, but not only for the Mekong, but pretty much everywhere in Southeast Asia. So we have quantified the illegal sand mining budget in the Mekong Delta by calculating the difference between the allowable extraction rates, which is set by the local, the provincial governments, to our actually measured sand mining budgets from the previous paper that I show you. So we found that illegal mining actually happens in several provinces. Here, as you can see on your the right figure, you can see the x-axis is the initial of the province. For example, DT is the Dong Thap, CT is the Kantha. These are one of the biggest mining provinces in the Mekong Delta, and you can actually see the permitted mining area actually like doubled in 5 or 6 years, and which is scientifically not possible, right? Because the river sedimentation and the replenishment rate does not vary this much interannually. So I think this indicates that very little science has been used to determine the allowable extraction rates set by the provincial governments. And we also confirm some of the specific case of illegal sand mining or something that is not accounted for. So in this map, the pink, the color that you see, also the blue, right? And they are the restricted zones where you are not allowed to do the mining. But during the same period, we found some of the sand mining activities going on in these zones, and the yellow here are actually the permitted zone for mining. And I think it's quite interesting that the permitted mining zone, the yellow color, is near the outer bank of the river, where the erosion happens naturally. So it's naturally not a good place to do the mining, right, to begin with. And I think all this implies that the fact that only little science has been used to determine the permitted mining zones. So actually, this illegal the sand mining is quite widespread, and also the enforcement is weak, and most of the official statistics are not too reliable in this region. So in our another study, published it recently, we look at the sand mining data sets at the country level in Southeast Asia, and we quantify the flow of the trade between countries, right? So this figure is actually showing the total volume of the sand each country has exported to Southeast Asian region, I think since 1990s. And the data set is based on the USGS, the cement data, and the UN Comtrade data sets. So countries like Malaysia, Vietnam, Cambodia, Myanmar, they were the highest exporters in Southeast Asia, that they have exported about more than 800 million tons. Well, when we actually look into some of the details of this data, it's actually very interesting that the imports and the exports, which is supposed to tally, does not really match very well. So this graph that you see on your left is actually the graph of the Cambodia and export and import to other countries, right? So this is the case that, for example, this column is a Cambodia exported to Singapore, right? But the column on the next one, on the orange color, is actually what Singapore has imported from Cambodia. So actually, there's huge gap, right? I think in case of Vietnam, the Vietnam says they exported this much to Singapore, according to the data sets, the international data sets. But the Singapore has imported more than the double from Vietnam. Actually, more than half cannot be explained. Actually, in December 2022, our team stayed in Chau Doc, which is the border town between the Vietnam and Cambodia, and we stayed in a hotel facing the Mekong River directly, and literally documented every boat that's passing through the Mekong River. And we found still a lot of the Cambodian boats with a full sand load crossing the border. But actually, both the Vietnam and Cambodia, they banned the sand exports officially in 2017. Well, anyways, there are a lot of the sand mining that's not accounted for, and we cannot really rely only on the voluntary report from the companies. But instead, we need a real measurement. So we actually came up with the sand mining budgets of the Mekong Delta. Firstly, with the Robin Gruel, first by the manually identifying the sand mining boats from the Sentinel images. But this is impossible because we need to upscale this, right? Because it's impossible, like for the whole Southeast Asia to do the manual mapping across the river, because rivers are big here, and there's like hundreds of thousands of boats on the river. The Mekong Delta itself, the water surface area is about 1,000 square kilometer. So we have developed, this is my PhD student's work, Sonu Kumar. We developed a deep learning model to actually automate the sand mining boat detection process in the Mekong Delta to estimate the sand mining, the budgets of the annual budget for the whole Mekong Delta. And we used about more than 10,000 training data sets for this. And now we are working on to expanding the deep learning based the sand mining budget estimation to the whole Southeast Asia, which is actually the global the sand mining hotspots, right? And we're currently targeting about 20 major rivers in Southeast Asia. But as you can see here, the challenge is that you can see from this figure that every country rivers, they have different sand mining activities. They have different dynamics and the patterns, and like the shapes and also the size of the boats used for sand mining is actually different from countries and from different rivers, which indicates that we need a separate boat analytics for the deep learning, the model training. So we have to tweak the model for every different rivers and countries. Okay, so and we're actually in finalizing another the small kind of research to understand better understand the vulnerability of the rivers in Borneo to the potential of the sand mining, because as you may know, Indonesia is relocating to a new capital in Nusantara in Borneo, right? Because the current capital, Jakarta, is not anymore the habitable, and of course this city the plan looks nice, but we need to think about how much sand will be required to build a new capital of such a huge country, and there will be the huge demand for the sands for all these large-scale the constructions, and those sands will likely to be sourced from the nearby rivers in Borneo. I think traditionally there were not much sand mining in the rivers in Borneo. I think the main reason is because Borneo is far from the major the populated areas in this region, but now I think their rivers are very much vulnerable. Okay, so that was about the extent of the sand mining. So now I want to move to a next section looking at the impacts of the sand mining, which is actually multidimensional. So the sand mining has the impacts on hydrology, of course, and geomorphology. I mean, because it's deforming the riverbed, as well as the ecology, right? Because and and also there are lots of social impacts as well, which is not really my own expertise though. And I have actually recently published one review paper on the sand mining impacts in the Mekong Delta, which actually gives kind of a similar overview of what I will talk about in this section. So to first look at the impact on the morphology of the riverbed. This is actually one of the river that's crossing the Ho Chi Minh City in southern Vietnam. So we have set up a two-dimensional hydrodynamic model to simulate the consequence of the sand mining. So basically looking at the morphodynamic changes. And the result is that the river flow has decreased and the amplitudes has increased mainly because of the incision of the riverbed, which in turn increased the sediment deposition in the estuary a little bit toward the upstream direction, basically changing the sediment transport regime. This study actually was the first river morphodynamic study looking at the sand mining impacts. So this the salinity intrusion is actually the critical consequence in the delta by increased backwater effect through the riverbed incision. So when you look at the salinity isoline in the Mekong Delta, you can actually see it has been gradually moving toward the land directions, right, every year. So and down here is a nice diagram by one of my colleague Bin, showing the mechanism of this. So sand mining will directly create the riverbed incision, which is going to decrease the water level of the river, right? And this decreased water level means the relative increase of the sea level, which extends the salinity gradient toward the inland directions, as you can see here. And actually, the salinity intrusion is actually a compound impact, not only from the sand mining, but also it is critically amplified by ever increasing the sea level rise, right, driven by the climate change. So this is really the salinity intrusion is really the one of the biggest the issues in the Mekong because usually it's closely associated also with the droughts, mainly because the Mekong Delta is basically a huge vast farm, mostly with paddy fields, which is not the salt tolerant. So more salt basically means less fresh water in the form of droughts, and this is a big pressure to farmers, right? And in this picture, all the river, the water and the groundwater is contaminated. So in case of 2020, so the government is trying to distribute the fresh water. Actually, another impacts on the agriculture is the decreased the flooding because of the decreased water level, right? Because of this, the reduction of the water level, it's going to naturally reduce the flooding, right? Of course, the too much flooding is a disaster, right? But the regular flooding is actually very important. The means of the water supply for agriculture in case of deltas. But this duration of the flooding in the Mekong Delta has decreased quite dramatically in the past 30 years, related to the sand mining, but also also related to the other the water infrastructure developments like the dikes as well as the upstream dams. And in the Mekong, there are different types of dikes to control not only the flooding, but also the seawater coming into the paddy field. So right now, there's no more natural flooding happening anymore in the Mekong Delta. Well, the decreased flood means also the consequence is the decreased the connectivity between the river and the floodplain. And I think the good example is the Tonle Sap in Cambodia. This is the biggest floodplain lake in Southeast Asia. And this is also a tributary of the Mekong. So this big lake has been shrinking since 1980s, but still there is no consensus on what is the main cause, what's the main driver of the shrinking. There are some of the candidates understanding of the the important drivers, but which one is more important than the others is still remaining kind of an unsolved question in the Mekong. So the right side here is actually the water level, right? And then the discharge data at the Phnom Penh station. So Phnom Penh is right at the confluence with the Mekong, at the Mekong with the Tonle Sap. We can actually see that the water level has been decreasing in the recent decades, right, in the Mekong River, but the discharge is not, right? And I was thinking how this can be possible without the significant changes in the riverbeds, the morphology. Well, and actually, the biggest and the most the rapid the riverbed incision is perhaps contributed by the sand mining beyond the erosion. And this is a very nice the bathymetry, the survey done by Chris Hackney. I actually before this presentation I was chatting with him on WhatsApp using the multi-beam near the Phnom Penh, right? And then you can see a lot of bookmarks created by the sand mining activities. You can imagine the scale of them just by looking at the individual bookmarks here. It can be like 8-meter depth and 40-meter long. And this big incision on the riverbed could have contributed also to the decrease in the water level of the Mekong, which in turn decreased the water, the fluxes into the Tonle Sap, contributing to its eventual shrinking. Another the crucial impacts on the sand mining is the riverbank collapse. So collaborating with local authorities and other colleagues, we reconstructed the bathymetry of the whole Mekong Delta over 3 different years of 2017, 20, and 22. And actually, we analyzed the riverbed, how it has been changing over the recent years. So the graph that you see on your right is the longitudinal profile of the How River. So basically showing the riverbeds, the elevation versus the distance along the river. You can see the significant drop in the average bed, the elevation over time from 2017 to 22. And down here is actually the difference between the different years. So the positive is, which is in the black color, is actually the aggradation or the sedimentation, and the negative is the incision, which is in the red color. And we can see that most of the reaches along the river in the delta has actually experienced the incision, right? But the whole delta is supposed to be an aggradational system. So some of the pictures from the field. So we used the ADCP and the echo sounder to measure the bathymetry, the flow structure, and also the discharge. And we surveyed many of the bank collapse sites and also measured the water quality near the sand mining hotspots to see if there's any changes in the turbidity during the sand mining activities. But I think the impacts on the turbidity is quite localized. So this is actually some of our survey results highlighting as kind of a link between the riverbed incision and the bank collapse. So this is the incision map along the one of the sand mining hotspots in the Mekong Delta, I think somewhere in the middle. And this cross-section data actually shows quite a dramatic incision that has happened in recent years. And we were also able to capture this dramatic, the sand mining bookmarks in our the side scan sonar images, as you can see here. So here's one interesting thing that I wanted to share. Is actually one of the very recent bank collapse sites, and using the side scan, the images, we could actually see some of these unconsolidated, the fresh sediments, which I think is the material that directly came from the recent the bank collapse. So these are some of the photos of the bank collapse that we took during the field surveys. The bottom has actually, like, the bank has really dramatically retreated and exposed the bottom structure of the building, which looks quite scary. I think we should not live here. On the right image, we can actually see these broken tiles of the roads and exposed muds. So here you can see in this image, you can see the road is actually destructed. It's basically broken. Simply, road is now disconnected, and then now people have to climb through the fence to get to their home. And you can actually see the warning signs pretty much everywhere. And the right side is my actually they are my undergrad students when we did field work last year. The photo shows the rebuilding of the bank using the concrete structure to repair the collapsed bank. But this structure looks quite heavy because it's not very stable landscape. And these are some of the embankments, the efforts going on, whether to prevent from the future collapse or to repair there after the collapse. But you can actually see the design is quite random and excuse me, and kind of not looking very solid. So people use like the sandbags, like this wood poles, and most of them are actually being done by the local people without much support from the government. So, as we just saw, there's a clear link between the sand mining activities and the bank collapse. But how far is actually the impact, right? This is something that we don't have good understanding yet. So surprisingly, lots of bank collapse actually also happen where there is no sand mining activity in the vicinity. For example, in this map, these like the stars, right, are the places where the critical bank collapse has happened, and these circles are where the sand mining hotspots, right, and which is quite far downstream, and this is because the bed incision gradually migrates upstream over time, as you can see in this right figure. So when there are sand mining extraction pits, over time it's going to cause the head cutting and the erosion longitudinally along the river upstream, changing the entire channel, the slope eventually. So we can see that the sand mining impacts on the bank collapse is reaching much farther the beyond the location of sand mining. Well, and related to this, what we still don't know is, I mean, okay, then, like, how far is the zone of impact? Like how much, like in the X amount of the sand extraction at certain location can increase like X% possibility of the bank collapse at what distance? So we need this kind of the quantitative understanding. Otherwise, we cannot really inform a concrete management plan, because in management you need a quantitative kind of like a threshold, like something like you cannot mine more than 500 tons in this area at a given time, something like this. So in collaboration with Josh at the Wageningen University in the Netherlands, this is also one of my PhD students' work. So we're developing a computational fluid dynamic model combined with a geoslope, the bank collapse model, to understand this difficult issue. But we don't really have yet much result to show. Okay, so during the field work, we actually saw like many people most of them actually farmers, right? Living on a very much vulnerable the bank, right? So they lost their homes, their like neighbor homes also collapsed, and some even lost their family members, but still living there on the vulnerable riverbank. And suddenly, we got interested in knowing what do they think about sand mining. So we interviewed about the 40 people, all the local residents, and surprisingly, our result is that most of them did not really perceive the sand mining as a major driver or the trigger of the bank collapse. The many of them cannot even link, this the landscape disruptions to the sand mining, but maybe it's related to. They said like it's related to wakes generated from the boats or the dams upstream somehow, or maybe like the climate change impacts. So all the social survey that we have done confirm the lack of perceptions or the awareness about the sand mining issues and the impacts among the local communities. Well, another study that we did quite recently also investigated the social impacts, but from the mining, the related activities. Actually, this is my undergrad students' work, just published in Annals of AAG. So here are our results to show that there were, the clear perception of the intense air, noise pollution because, the once the sand is extracted on the loaded on the transport boats and reach the shoreline of the river, there are so many. This is the sand reserve. People use a lot of trucks to transport the sands on the land, and it actually damages the urban landscapes, right? And that disrupts the local livelihoods and causing kind of a loss of their sense of this place. Okay, so moving forward, what we should do to tackle, address this critical environmental challenge. So this is actually the last part of my talk today. So the first thing that we have to propose is the sustainable mining, right? As you can imagine easily. So because the sand mining will never stop anyways, because developments will never stop, right? Then we have to find the more practical and the reasonable to do the mining, like the location where we can to minimize the environmental impact while getting the sand that we need for the developments. Well, surely the rate of the sand mining in the Mekong is not sustainable, and the one of the way that we confirm this is by mapping the recurrence interval of the sand mining boats in the Mekong Delta. So basically, you can see this bar graph here. The most of the sand mining boats came back to the same spot within 2 years' time. And surely, this is not long enough time for the river to recover from the previous mining activity. Well, the second thing that we need to do is simply putting more the stricter enforcements and a science-based regulation. I came up with this idea because when we look at each environmental the issues in the Mekong Delta, these are the four major environmental issues that we identified. Actually, among them, the sand mining is relatively easier to control when you compare to the other because of the scale of the driver and also the scale of the impact. Because the mining happens at least inside Vietnam, the country's boundary anyway. The other pressures like the managing the dam issue is much more challenging because it's a transboundary discussion involving the many countries in the upstream of the basin. Likewise, the climate change actually is even a global scale issue where individual countries cannot really do too much about it. So lastly, and perhaps most importantly, I think at the end we all need to adapt to the changing environment, basically to become more ourselves more resilient. And of course, we need to build more the solid knowledge basis, like how we can, do the adaptation for the Delta communities. And I think the nature-based solution which is becoming really popular these days. It's efficient in tackling the compound the impacts in different river deltas around the world. Well, in case of the Mekong Delta, the farmers are actually practicing what's called the rotational the crops. Basically, the cropping rice during the wet season when the river discharge is higher, and convert to fish and the prawn during the dry season when there's the salt water coming in from the sea. And I think this is a perfect adaptation example to this intensifying the salinity intrusion. Okay, so I came to the end of my presentation. I will stop here, and I have to acknowledge several projects from Singapore, which made all this research possible, and also my team members. Thanks to all of them. Thank you so much for listening.
Thank you, Edward. Thank you very much for this very interesting and important discussion. Let's open the questions to the public. Please write your questions in the comments, and we are going to transfer the question to Edward. Por favor, escriban sus preguntas los comentarios y nos vamos a informar a Edward sobre sus preguntas y responder las mismas. Currently, we have a couple of questions. The first one, by Ellen Lima de Andrade, say, in what way does sand mining in the Mekong Delta exacerbate the effects of climate change, such as sea level rise and soil salinization, and what mitigation strategies could be implemented? This is the question.
So I'm reading the question now. So the question is, in what ways does sand mining in the Mekong Delta exacerbate the effects of climate change, such as sea level rise and soil salinization? What mitigation? Well, I mean, this is actually, all about, the presentation. Well, in my opinion, because I have been working on sand mining issues, its drivers and impacts for the past few years, in my opinion, I see several links to the climate change, whether the climate change impacts sand mining, also the sand mining impacts climate change, but literally there's no study about this. So just to give you a brief idea of what I think, sand mining, basically they use boats, right, which actually consumes a lot of the fuels and creates lots of the emissions to the atmosphere. This should be also, in my opinion, quite significant part of the greenhouse gases. And also the climate change impacts on the sand mining. Climate change basically changed the patterns of the rainfall and the temperature in the mountain areas, and that actually shift the regimes of the sediment, the weathering, and the erosion, and also going to impact the deposition pattern. So it's going to change the availability of the sands in the downstream area. It's going to, and the consequence will be impacting the price of the sand, right? So I think there's quite an importance, the link between the two, but it's still to be investigated. And as I mentioned, for example, like the soil salinization, this is a compounded impact. The sand mining contributes, but it's not only by the sand mining through the riverbed incision, but also the upstream dam, which blocks the sediments, and also the climate change driven, the sea level rise, as well as the groundwater extraction, which is happening a lot in the Delta area, that actually causes the land subsidence, also contributes to the soil salinization. Yeah. I think that should be enough for this question. Yeah.
Okay. I have another question here by Kalina Faria. The impacts.
Yeah, I can read it. Yeah.
Yeah, you can read it. Okay.
Yeah. Okay, so impacts of the sediments extraction are important. Is there any regulation authority, mechanism that directs mitigation recovery? Well, yes. The answer is yes. The problem is the enforcement and the management of this activity. As I mentioned, the illegal sand mining is quite widespread in many of the parts of the important deltas. And I think the main reason is because, firstly, the river is really big, right? And then there are thousands of boats there. And in case of Mekong, what actually complicates is in the Mekong Delta, there are 12 provinces, and each province have a different regulation, the policies, right? So, for example, like one boat does the sand mining in province A and can cross the border to go to the province B, but there's actually no way to identify where their extracted sand comes from. So there are lots of gaps in terms of policy and the management strategies to be filled.
We have another question by Jorge Abad. Welcome, Jorge. Nice to have you here. Can you
Yeah.
post? Yeah.
Hi, Jorge. Good to see you again. So, at deposition erosion occurs in different locations. Sand mining disrupts it, and the bank erosion. Based on ADCP, did you notice flow structures, the shear stress changes? Well, this is actually the one of our research wants to figure out. Actually, haven't noticed yet, but conceptually, we know that it changes the shear stresses and the flow structure. But also in these sand-bed rivers in the lowlands, what we also have noticed is the recovery of the beds is quite fast than we expected. So after we revisit the same spot after 2-3 years, most of the cases, the big poke marks are gone, and the river course has gone back to its natural, the shape of the bed. But yes, this is something that we're investigating, and then this is what people are talking about, the sand mining impacts on the flow structure and the bed shear stresses. Can I just go ahead?
Yeah, it's okay.
Is sand excavation poverty driven? Is it a result of climate change in that there's no other opportunity? Well, I'm not sure it's right to say that, but actually the sand is actually the big source of income, not only for the company but for many of the nations in this region, and then it's and of course the unit price is much cheaper than like gold or diamonds. So this is actually a good way to generate the revenues and not without too much the cost, but they should also understand that the sand is not going to be there forever, right? Because it's a second most extracted natural resources after water, and it's also finite resource. What are the mechanisms for mitigating and adapting to the impacts of sand mining? Mitigating, adapting. Well, so in my presentation, in the last slide, I have proposed actually three. So I think the most important is the sustainable mining. So the stopping the sand mining is impossible because we need sand for developments. So I think the realistic alternative is to find a way to extract the sands while minimizing the environmental and the social impact. And actually, many of the countries, they banned the sand extraction from the river. Instead, you can use the crushed rocks, right, from a bit upstream. But that's actually a lot of extra cost. But that's actually one of the alternative that many of the nations are doing as well. So is sand mining in a way sustainable? In any way sustainable? What is the time frame for severe and the permanent damage to nationwide effects, then global effects in relation to fishing stocks? Well, Okay, so this is another research gap. We all know conceptually, as a river scientist, the impact of the sand mining on the ecology, especially this riverine ecology, because to simply put it, uh, a lot of the deep pools in the river is basically the habitats for all this the fish. So there are impacts, but there's no the quantitative study. And I think to scientifically address the link between the impact of sand mining to the fishing stock changes is quite challenging. But actually, we all know that there is a clear link. Yeah, and you also mentioned about the scale. Well, for example, like the Tonle Sap, which is one of the most important, uh, the lake and a source of protein because of the fishing industry and community. Of course, it's in a risk because of shrinking and the less and less inflow from the Mekong. Um, yeah, and I think the similar for the Vietnam as well, because of all these bad disruptions. Okay, I think that's it for the comments. Yeah.
More questions, comments? Please write it. Very good. I think that we don't have too much an additional question. I believe that thank you very much. It was a very interesting topic, very relevant, not only for the area, but it's a topic of global interest. I have some points. I think there has to be probably, you can explain a little more, is that the budget is altered, is modified because we have a lot of dams also in the basin, right? We have several dams along the main channel. We have more than 160 probably in the basin. So all these have been cutting or altering, affecting the sand supply. I consider the Mekong a pretty simple river, considering the comparison of the Mekong with other big rivers. It's kind of a corridor with very little lateral activity. But my point is, what indeed, see, we are extracting sand from the bed. Of course, we are not being capable to recover because we are trapping a lot of sand in the different part of the basin, right? So I think the design mining is a combined factor with the decrease of sand supply plus the mining are doing these effects. I mean, it's not only the mining who is triggering it, but like in the design and in the picture, it's the figure that you shown from Condolf, as you say, okay, we recover the we had the pit and we recover a little the river. It's a very localized example, but it's very much complex than that. The point is that the river has not this capacity because the sand display is smaller than before, right?
Yes.
And this
Yeah.
is a
I
very
mean,
point.
yeah, that's a really good point. And yeah, so as I mentioned a couple of times, for example, the riverbed incision as a consequence is a salinity intrusion. It's a compounded impact from the multiple drivers, right? The dams, in case of Mekong, the more than 90% of the loads, the sediments loads are disrupted and they're trapped in the dam. So a very little, actually almost no sand coming down. So basically, we are eating up what has been deposited,
That's the
throughout the
point.
sea,
Yeah.
and then also more interestingly and importantly, how it's going to change in the future in the face of climate change, right? Because it's going to impact the regimes of the weathering, and also going to impact the supply of the sand, but also the the high energy demand in this region. I'm also I know also in Brazil is the similar situation, because the dams are the proliferating in still in Southeast Asia, uh, in the face of the renewable energy. So how it's going to change this supply and the demand, because demand is also increasing, right? Because of this the urbanizations, and the desire for the developments of many nations. So how it's going to change the supply and the demand, availability of the sand, the price of the sand, this is something not easily predictable, and nobody have looked into this issue yet, which I think is very important.
Yeah, also I think that regarding the model that you presented as one, I think also depend on the Mekong have a very control of geomorphologic control by ridges, because we have neck points through the main channel, and we have also a strong change downstream Phnom Penh with a couple of ridges. This is more straight one and a branching one, and after you entering what the people broadly call the Mekong Delta, but indeed is not the Mekong Delta at all. So the huge area of quaternary sediment that people usually call the Mekong Delta is in reality all the quaternary units. So the Mekong Delta, the real Mekong Delta, is pretty small. It's the Holocene sediments close to the mouth, right? So that's my question about what you are looking about the modeling bank erosion. I think it's probably, focusing on the different ratio with the different processes is easier than trying to apply physically model bank erosion using shear stress and so on, because it's not true that you are going to remove sand from the bed, and for this reason you are going to trigger bank erosion by changing the shear stress in the banks, because the bank mainly uncohesive material from the Pleistocene or whatever. Right? It's a good part of the lower Mekong is through that. That's the reason there is practically no lateral migration in the river. It's very stable stuff, right? So I understand that can be a concern for local people, but compared to other rivers, the lateral migration is pretty slow.
Yeah. There's actually one more question. Should I go for it?
Sure,
So,
absolutely.
so are there no substitute like mining waste? Oh, this is a really good question. So this is my kind of perspective. There are researches being done to develop like an alternative materials, and also in Singapore. But this sand, the demand is at a global scale, and in my opinion, many of them, the like the new materials or the recycled from the waste requires technology and the cost, which most of the countries cannot afford, right? So oftentimes it can be teasing. So yeah, there are researches and there are alternatives, but then we have to the practical implementation is another issue that we have to think about. Yeah. Yes, as you say, yeah, the cost is the primary the driver for the supply. Okay, I think that's it for the questions here.
More questions? It's your opportunity, guys. Do the
Yeah,
questions together.
yeah. Feel free to email me.
Very relevant.
Yeah. And I would love to develop more the connections and collaborations with South American the researchers yeah, for this sand mining related or any other the river research.
Very good. No more questions? Okay, yeah, but I think that this is enough. You're going to be free of this. Thank you very, very much for your collaboration with our seminars. Thank you all the public, all the audience for participating, for raising very important and interesting question as well. It's very important having this interaction between the speakers and the audience. So it's a high point of the seminars. And Edward, thank you again. Congratulations for your fantastic work in Southeast Asia. And of course, we are always open here for collaboration and so on. And thank you, everybody.
Thank you.